Thanks for joining the Caneberry Educational Conference as part of the 2021 Virtual Southeast Regional Fruit and Vegetable Conference. I'm Margaret Worthington, an assistant professor of fruit breeding at the University of Arkansas, and I will be the moderator for this session. I'd like to thank Wish Farms for sponsoring the Caneberry Educational Conference and also for giving us Jose Saca as a speaker. So, the pesticide CEU and CECCA credits are available for most presentations offered during the Southeast Regional Conference. Check the pesticide CEU guide for a list of approved presentations and also the participating states. The pesticide CEU guide is located in the Event Resources tab under the Media Player. The guide is also available at the Resources Center located on the main menu of the conference platform. Please note, pesticides credits will only be available for 1, registered attendees, and 2, they're only during the live conference. So credits will not be available for on-demand viewing. So, the pesticide CEU process. There is a simple 3-step process to receive pesticide CEU and CCA credits. First of all, you go to the audience chat box. It's located on the left side of your screen. Type your first name, your last name, and the states for which you are requesting credits. Again, go to that audience chat box located on the left side of your screen. Type your first name, your last name, and the states for which you are requesting credits. You're going to need to do this for every presentation that you request CEU credits for. Now, the second step is to sign out at the end of the presentation. To sign out, go back to that audience chat box, type your first name, your last name, and the states you're requesting credit for, and you are going to be reminded to sign out at the end of the presentation. The third and final step is to complete the pesticide CEU registration. You only have to complete this registration one time during the conference. It is not required for every presentation. To access this pesticide CEU registration web link, open the pesticide CEU guide on the Event Resources tab located under the Media Player. The pesticide CEU registration web link is located on the front cover of the guide. Okay, so this presentation is pre-recorded to reduce technical difficulties. We are going to answer your questions live at the end of the presentation. Please submit a question at any point during this presentation by typing your questions in the questions box and pressing send. And I will say that we really want this to be an interactive session, and so I hope you will participate and we can have a good discussion after this is finished. Lastly, I want to thank our 2021 conference sponsors and exhibitors, and you can thank them by visiting the virtual trade show and the featured products pavilion. And remember to participate in morning coffee chats each day and each evening in the networking. And you can check the conference agenda for details on all of that. So, with that, let's get started on our presentation. Today, we're going to be talking about perspectives on red drupelet reversion. So I'm speaking along with Jose Saca from Wish Farms and grower Marvin Williams, and we're going to talk about research perspectives, shipper perspectives, and grower perspectives on this problem. So again, I'm Margaret Worthington, and I am an assistant professor of fruit breeding at the University of Arkansas. So many of you know John Clark. I've been hired to be his colleague and eventual successor in the blackberry breeding program. And one of the ways that I've been getting my feet wet with blackberries is handling a lot of our research agenda. And a topic I'm really excited about is red drupelet reversion. So I'm going to cover some research that we've been doing at the University of Arkansas and also research done in other parts of the world just to let us know. I'll keep up to date on what is the current state of research for this problem. So for consumer perception of red drupelet reversion, this is why this is a problem. Consumers do not like red drupelet reversion. We had a online survey conducted by Renee Threlfall, who is a colleague of ours on the food science department. And she asked 879 consumers which of these photos of clamshells was most preferred. She had this one that had no red druplet reversion, this one in the middle that had a moderate amount, and then one on the far right that had quite a bit of reversion. And 73% of people preferred the one with the least reversion compared to only 7% with the most reversion. And we asked people to give our comments about why they made that selection as well. And most folks had indicated that they thought that number 378 looked unripe. Of course, we know that that is not what is happening with red druplet reversion, that these were picked fully black, but consumers don't know that and they think it's unripe and they just haven't turned black yet. The 7% who did like 378 thought it looked fresher, probably because they thought it was unripe. But we also had similar results in a subsequent in-person consumer panel. So it's a pretty consistent result that people prefer to see a fully black druplet. Now, there's a huge economic impact of this disorder, right? The specific statistics on the economic impact are lacking. We don't have that information about how much money is lost, but we know it's a major concern of shippers and marketers, and that a lot of fruit, approximately 35% of fruit, is rejected at packing, cooler, or at the retail customer. And that's unacceptable. So we want to move blackberries off the shelf. We don't want products rejected. And so we need solutions for this disorder. What we know about the factors affecting red druplet reversion is that we have interaction of cultural practices that can impact how severe this disorder is. We know there's a big effect of cultivar or genetics on how severe it gets, and also post-harvest handling practices. And a lot of the recent research that has let us know about this stuff was conducted by a PhD student at the Tasmanian Institute of Agriculture, Dr. Max Edgley. He did an excellent job, and he was actually a speaker in this session in 2019, and he's published a lot of his research since then. So I'm going to kind of review some of the work that he did, and I want to make sure that he gets credit for his really excellent doctoral work on this subject that helped us to learn a lot. So what causes red druplet reversion? The short answer is that it's cellular membrane leakage and anthocyanin degradation. And I'm not a biochemist, but I'm going to give a little bit of background about what causes this disorder. Basically, anthocyanins, and specifically the anthocyanin cyanidin-3 glucoside, is what gives blackberries their nice characteristic dark color. And here we've got a little picture of the pathway where anthocyanins are synthesized. It's a lot of detail, and I don't fully understand it myself, but they are synthesized in the cytosol, and then they are sequestered in the vacuole, which is basically just a little storage compartment in the cell. And the vacuole protects these compounds from different other compounds, polyphenols, polygalactonurases, that come and break them down, these enzymes that break those anthocyanins down if they're left in the cytosol. And it also is a very low pH environment. So if they are left in the cyanol, we know that they break down. In the cytosol, we know that anthocyanins break down. There's a higher pH where they're unstable, and there are also a lot of enzymes that are hostile to anthocyanins out there. And actually, at the transporter stage, after anthocyanins are created, you often see mutations in this GST gene, that is the transporter that takes them to the vacuole. And what you get then is white flowers, white corn kernels, or bronze muscadine. So this is the gene that causes the difference between black and bronze muscadines. And my point here is that the anthocyanins break down and you lose color when they are not in the vacuole. So next. We know that membranes and pectins naturally break down during fruit ripening. This is what makes fruit soft, like those nice melting peaches we enjoy. And it also makes that fruit more susceptible to mechanical damage. So in red druplet reversion, you have membranes that are breaking down, and that's breaking down the tonoplast, which is the membrane around the vacuole, and you have the contents of the vacuole spilling out into the cytosol where those red druplets have their anthocyanins degraded. And Max Edgley has done a number of studies on this. He's shown here that you see cell membranes that are quite intact on this picture up close of a black druplet, and here in the red druplet you have a lot of broken down membranes. So we know that red druplets have less anthocyanins, particularly the cyanidin 3-glucoside, which is the dominant anthocyanin in blackberries. Here on the right, you can see some work that was done by Kim et al., a group in Korea. They looked at red druplets in Apache, Wachita, and Triple Crown, and you can see the dominant anthocyanin, cyanidin 3-glucoside, and total anthocyanins below. And basically at harvest and black druplets after storage, you have in red and green, and you can see that they are much higher than C in the red druplets. Max Edgley also did some work on this with Wachita blackberries specifically, and he found a 59% reduction in cyanidin 3-glucoside in red versus black druplets. So that's a little bit the short story or the long story, depending on your perspective, on what causes red druplet reversion. Now I'm going to talk about factors that impact how severe this disorder is. So the first area we're going to talk about is cultural practices. Max Edgley also did some work on nitrogen. He grew Wachita in a tunnel with 3 nitrogen levels over 2 years in Tasmania. And the three levels that he used were 47 pounds an acre, 95 pounds per acre, and 189 pounds per acre. And so these are all relatively high for us. I think 47 pounds per acre would be pretty high itself for a southeast grower, and this 189 pounds per acre is a little bit ridiculous. But he basically did find here, you've got the high nitrogen treatment on these graphs in orange compared to medium and green, and blue is the low. That generally speaking, the high nitrogen treatment produced more red druplet reversion than the low and medium nitrogen treatments. I mean, for most of our growers, you're never going to put that much nitrogen out there, so I'm not sure how relevant that is. But we know that nitrogen can have an effect. It also produced more fruit than the other treatments, but I don't know that the yield was made up for by that, the cost and, of course, the red druplet reversion. Next, I want to talk about heat at harvest. So Max Edgley also did some work measuring in the same study the heat. And he noticed that when harvest was over 23 degrees Celsius or 73 Fahrenheit, he had a higher incidence and severity of red druplet reversion in 2017. And in 2016, he had no harvest over 73 Fahrenheit. Ha ha ha. That's kind of irrelevant for us. I feel like 73 would be quite a cool day for a blackberry harvest in the Southeast. But he did have some data that was a little bit warmer. Here you can see he had harvests that were at 87 degrees Fahrenheit down to 55. And he did find that harvests that were later in the day at noon and at 2 p.m. where the temperatures were reaching 87, he found a higher incidence and severity of red druplet reversion. And we have done some research on this at the University of Arkansas as well. So in a climate that's more similar to what y'all are dealing with. My master's student, Mitch Armour, did a 2-year study where he looked at red druplet reversion in 7 blackberry genotypes from our breeding program that were harvested at 7 a.m., 10 a.m., 1 p.m., and 4 p.m. And as y'all can see here, he harvested on 2 different dates in each year, kind of a factorial treatment and design here. And it did get quite warm in both years, so pretty typical weather here. And what he found is what we expect, that basically blackberries harvested earlier in the day when it's cooler had less reversion. That was true for all 7 genotypes harvested. And I'll note that overall, he had a lot worse reversion in 2019 than 2018. Here on the right, you can see that our average red drupelet reversion was, less than 10% of reverted druplets in 2018, with really low reversion here at 7 a.m. and then peaking in the afternoon at 4 p.m. In 2019, again, he found the lowest reversion at 7 a.m., but his highest reversion was at 1 p.m. with 30% reverted druplets or reverted berries, and intermediate at 10 a.m. and 4 p.m. So basically harvesting at 7 a.m. was much better in both years. And I'll note that the reversion was much worse again in 2019 than 2018, even though it was actually hotter in 2018. And I think that there may be an effect of rain on that. We didn't harvest within 48 hours of a rain event, but we did have a rainy June in 2019. And so I think it may be worth investigating in the future rain or irrigation effects on red drupelet reversion. And I'd be interested if anybody has any thoughts in the comments. Have y'all noticed a relationship and as growers or shippers with rain and irrigation effects on red drupelet reversion? So the next thing we'll talk about is damage during picking. Another study that Max Edgley did was that he had 2 harvest handling treatments. So he had first the kind of standard practice where somebody is hand harvesting blackberries into shallow buckets and then transferring those to industry standard 125 gram clamshells. And again, this is with Ouachita fruit grown in a tunnel in Tasmania. And his second treatment was to have somebody individually snip off each blackberry by the pedestal without touching the fruit and place into cotton wool lined trays. And he found, here's a picture of the fruit that was harvested, without touching the fruit by the pedestal. And here is a picture below of the fruit that was harvested by standard practice. And 85% of the fruit harvested in the standard treatment had some reversion at least, compared to only 6% of the fruit without any red drupelet reversion. So I would say that harvest practice number 2 is not very practical, but there was an impressive effect there. So it's something to consider. We know that there's mechanical damage that's happening during the harvest practice. And so are there implications for clamshell design? That's one thing he suggested. Something that you could tell your pickers about not being too rough with them. Obviously, you're not going to be picking like treatment number 2 there, but we know that damage during picking is one thing that contributes to red drupelet reversion. So the next area I want to talk about is research on post-harvest handling. The rate of cooling seems to have an effect. This is another study that was conducted by Max Edgley, and it hasn't been published in a full journal article yet. It's just in a fact sheet. But he looked at fruit that was bruised initially at different temperatures, so at 59, 77, and 95 degrees Fahrenheit, and then he cooled that fruit rapidly versus slowly. And again, this was like not very much detail given, so I can't say what exactly constituted rapid versus cool, but he found much higher rates of reversion with this fast cooling rate in orange than he did with the slow cooling on blue, and the effect was intensified the hotter it got when you were doing the bruising. We also know that maintaining the cold chain is important, and I haven't seen specific research on heating up and cooling down blackberries and the effect that has on red drupelet reversion. But we just know this by talking to our commercial partners who have found that if the cold chain is broken, if something goes wrong during shipping, that red drupelet reversion is terrible. And I'd be interested to hear more from growers and shippers in the audience and the other speakers about what they found about what is the appropriate way to cool blackberries to minimize red drupelet reversion. I also want to talk about vibration during shipping and that's effect on red drupelet reversion. There was a group out of Mexico led by Perez, who did a study where they investigated the effect of transport vibration on color reversion. So they looked at They took boxes with 12 6-ounce clamshells of Tupi, and they vibrated them on this fancy vibration machine that they had between 5 and 30 hertz with an amplitude of 0.5. And they found that at a frequency of 10 hertz with 0.5 amplitude there, they generated color reversion and internal cellular damage. And they have a picture here from their paper of control fruit versus that vibrated fruit. And they felt that that was a good simulation of what a Tupi blackberry would experience going down a dirt road in Mexico in the back of a truck. So we do know that that vibration during the shipping process can affect blackberries and red drupelet reversion. However, you know, it's not clear to me exactly how you would get around that, but maybe, again, there's something to do with packaging that could affect this and minimize the problem. Now, the last area that I want to talk about, which is my area, is genetics. So we know that there are genetic differences in susceptibility to red drupelet reversion. There are strong varietal differences. You know, we hear all the time complaints about Primark 45 reverting, and I've heard that, you know, from growers in North Carolina and in California this year. And we have found pretty consistent rankings across years in our studies about what reverts and what doesn't. My STAIN master student, Mitch R. Moore, who did the study about time of day, he had the 7 different genotypes in his study. And we picked these to be a range of our cultivars with different fruit textures. So we have Black Magic, which is a soft home garden cultivar. And we also included A2453, which is not a released cultivar from our program, but it's an advanced selection with crispy fruit texture. So it's very, very firm. And here you can see that the rankings were pretty consistent, that the very firm types had the lowest reversion in both 2018 and in 2019. And Black Magic was particularly bad each year, much worse than all of the other genotypes. And then you have some intermediates here, Natchez, Primark Traveler, Primark 45, and Osage and Ouachita also performed very well for us in this trial. Have growers and shippers in the audience found that any cultivars perform especially well or poorly? That would be an interesting thing for us to discuss. So put in the comments if you have any thoughts on this. I want to talk a little bit about the genetics of crispy blackberries here. So these are a couple very, very firm selections that have been identified in the University of Arkansas breeding program. It's a trait that is pretty distinct from our normal firmness, something like Ouachita. It has a texture a little bit like a pomegranate aril. They're really an interesting texture and something that I like and that has generally been pretty well received by consumers and consumer panels that we run with food science too. They do outstanding in post-harvest evaluations, and they have very, very low reversion compared to other modern cultivars. A PhD student with Dr. Clark, Alejandra Salgado, did a study where she found that Natchez had 41% reversion compared with 13% in 2453. So they do a lot better. And over here on the right, you can see some pictures just showing that the cellular membranes seem to be more intact in these crispy ones than the normal textured blackberries. We think there's something about cell wall degradation that is different in these during ripening. So they're pretty exciting, and you may think, great, all right, release these already. But we have had some issues. I don't think it's anything specific to this trait. It's unrelated. It's just that we happen to have yields that are about half of our Czech cultivars and small berry size as problems in these 2 advanced selections. So we're not sure that these are suitable for public release at this moment, but we are trying to move this exciting trait into our other high yielding, great tasting material to get this out to growers. So here, talking a little bit about firmness, here you can see plotted the relationship between fruit firmness and red drupelet reversion in 2018 and 2019. They are correlated with more reversion on black magic, this real soft genotype, and less reversion here with these real firm genotypes like A2453. And this has been documented in many studies, but a lot of the genetic variation in red drupelet reversion is still unexplained. So Osage in particular, and also Ouachita, did a lot better. They had a lot less reverted berries on the x-axis here than you would expect, considering how firm they are plotted on the y-axis. And so one possible explanation for capturing some of this variation that we can't explain with firmness is that there could be some changes in anthocyanin composition. We know based on the research by Max Edgley and by Kim et al. That some anthocyanin types seem to revert more than others. So cyanidin-3 glucoside, it's pictured up here. It's kind of a more simple anthocyanin. That is our main anthocyanin in blackberries, and it is particularly unstable. But there's another anthocyanin, cyanidin-3 rutinoside, that is not nearly as common as cyanidin-3 glucoside, but it's also found in blackberries. And here it's pictured on the right down here, and it's got this extra sugar group on there. And basically, the more hangy things that are coming off of an anthocyanin, the more stable it is. And so this is thought to be a more stable anthocyanin. And interestingly, this is also the most common anthocyanin, cyanidin-3 rutinoside, in black raspberry. And we don't see reversion in black raspberry like we do in blackberry. We know that there's variation existing for this compound among cultivars. My student Mitch found that Osage had significantly higher cyanidin-3 rutinoside than the other cultivars in 2019. So maybe that's partially contributing to why it is better in reversion than we would think. However, it's real preliminary data. Also, Kim et al. In the Korean group, they found that Ouachita had significantly lower cyanidin-3 rutinoside compared to Apache and Triple Crown here on the sides. And you can see that this is losing some of its anthocyanins in the blue compared to the green, but the rutinoside is retained a lot better than the cyanidin-3 glucoside. So my question is, would it be possible to breed for stable anthocyanins and increase cyanidin-3 rutinoside in blackberries? And that's something that, I can work on over the next 10 or 20 years. So I want to talk a little bit about a couple other things our group is doing. I have a PhD student, Mason Sizik, who's doing a real nice job trying to develop ways for us to screen for red drupelet reversion on a lot of different blackberry genotypes. He developed an image-based analysis protocol. So he basically puts the blackberries on a green screen like the blackberries are a weather girl. And we are able to take those pictures and separate out the blackberry pixels and then the red drupelet pixels by setting different color thresholds. So here he's able to estimate that 2.17% of the drupelets here, or the pixels, are reverted. And he's found that that has an 80 to 85% correlation with the manual scoring methods that we've used. And if anything, I think it's probably better and more consistent. And he's viewing this, he's measuring firmness and red drupelet reversion in at least 500 samples every year, trying to estimate this in our breeding program. And his ultimate goal is to develop genetic markers that we can use to breed for crispy texture and get new products out to growers with that crispy texture and low reversion faster. I will say we've had some problems that, as much of a problem as red drupelet reversion is for growers, we often do not see it in a major way in our breeding trials. And probably that's because our breeding trials are babied. We have grad students lovingly placing these berries into their clamshells, and we see very low reversion rates here in this middle plot compared to what we would expect in a commercial setting. And so he's able to find a relationship between red drupelet reversion and firmness, but it's weaker than we would think otherwise because he is seeing such low reversion. So I'm also working with him to develop standardized methods for increasing our red drupelet reversion for screening purposes. And that's we have a little vibration table that we made similar to what the Perez group has, where we can set up to a certain amount of vibration, pretend that the blackberry is on a truck, and hopefully increase the amount of reversion that we see in our breeding program. Because we often don't find that Primark 45 reverts very bad in Clarksville, but we know that it reverts bad with growers. So we want to make sure we're doing the best job selecting low reversion material that we can. And I want to thank all of the different staff that work in the blackberry breeding program at the University of Arkansas and have helped us with all the research that we have going on. And I'd also like to thank financial sponsors of our research, including the Southern Region Small Fruit Consortium, NARBA, and the USDA AFRI program. So, if you have any questions about the research that I have summarized here, then please put it in the chat box and we'll get to it at the end. But now I'd like to turn over the presentation to Jose Saca, who is the director of Caneberry at Wish Farms, one of our sponsors of our session. And he's going to take over and tell us a little bit about his perspectives on this problem as a shipper. So, Jose, take it away.
Thank you, Margaret. Nice presentation. Very, very, very helpful. It answered a whole bunch of questions I had about this and created even more. So we got a long chat coming. I got the shipper perspectives, and I'm the director of Caneberries for Wish Farms. My job here is pretty much source caneberries for 365 days of the year, whatever they may be grown, and that's what I do for a living. Let me first of all, I wanted to. Some of us talk about reversion and what it causes and everything, but we all talk about the U.S. #1 standards, which is how we sell, and this is how the clients, our retailers, buy it. They demand that our fruit be U.S. #1 or better, and this, what you see here, is out of the standards for the USDA 1. And it says clearly, it says consists of dewberries or blackberries of one variety which are firm, well-colored. This is the problem, the word well-colored, well-developed and not overripe. Nowhere in there it tells you anything about these red druplets, but everybody goes for the well-colored. The inspectors think that fruit with red regression is not a well-colored fruit. So that's where we get in trouble. So I even put the definition of the well-colored. What the USDA means for well-colored means that the whole surface of the berry shall be blue or black in color. So with that, they and because they know that it is a problem in blackberries, they even had a special section called the for the red drupelet disorder in blackberries, and then they get into a little bit. And it says in there that this disorder is specific to blackberries, and we know that. Red drupelet disorder can cause individual droplets to change colors, swollen and everything. It really doesn't change flavor. But it does affect visual, and the scoring guide. This is for the scoring guides, is how they train their inspectors and how we train our inspectors to look for this. So the scoring guide says a slight discoloration affecting individual droplets that are reddish black or reddish blue, and blending colors. A discoloration that is noticeably bluish red to bright red and not blend in color will be considered as damage or serious damage. It is important to consider that the color and number of this affects the druplets. The brighter and more distinct the discoloration, of course, the worse, the less allowance. So damage is when affects a little bit of the appearance. And this is where my interpretation as an inspector might be different than yours, so there is a little bit of a human touch in there when the inspector is looking at it. And a serious damage is when seriously detracts from the appearance of the fruit. And then they also include pictures in this guide. And you can see that they still consider US number 1, the first one to your left. And you can see that there are some red druplets in there. This is allowable. And then the one in the middle has some, and of course the one on the right is a serious damage. And we can all agree on this. This is pretty clear. But the important part is that, yes, it is. There are some allowance in the book, but it all depends on your inspector and if you're calling a federal or the guys at the dock or our QC people at the coolers. The following is how this affects us, wish farms. And these are quality defects from all the blackberries I received during the Mexico season during 1920. And 39 of all the defects that we categorized were due to the regression, and followed by 27% of soft and leaking. And by what Margaret just showed before, it says that the ones that are fruit with regression is softer and it will tend to leak because of the. So all those things make sense now with Margaret presentation. Regression is a major issue for us, for our growers, and for our receivers. This is the one for Mexico, and this is the same, but for Georgia and North Carolina fruit that we received actually this year from May to September. Here you can see that from all of these defects that we had, 50% were red cells. Leakers. So that means that when the guy takes the fruit and takes a sample and he starts looking at it and he scores it, 50% of the score was due to red cells, which also matches pretty close to what Margaret shows, that I think it was 39% of the problem. Well, we match pretty good. So it's validating that research that she showed us earlier. That means that we're no worse or no better, but doesn't help me at all. What we notice is there's certain things that we notice, and she covered them pretty well. Georgia's pretty hot, and North Carolina's pretty hot, pretty much all the time, especially harvesting, some rains. And in the Mexico thing, we have noticed that it's especially bad regression early in the season, which is very warm and hot. It's in September and October. There's still some rains coming, and it's very hot. And then towards the end of the season, which is in May, which is also rainy and hot, that's when we get more in trouble in Mexico with red cells. In the middle, like right now, that is cooling and temperatures, environment, weather is probably low 80s, higher 70s, and the low 50s, and upper 40s at night. Regression kind of disappears, even though they're still traveling the same trucks before and after, but it does affect the trucking if it gets a lot of jarring in the truck. And we have noticed also that the top layers sometimes, especially in the early season and late season, the top layers of the pallets, sometimes it's the first one or the first 2 or 3 that are super red. All that fruit is thrown away pretty much. And instead of having 240 boxes in a pallet, we have now less. We had 200, 192 because the top 3 are thrown away. And they time really well because we understand, that the movement does affect this. So they time really well in order to minimize that vibration. But I guess, like she said, it's dirt roads. It's pretty hard on them. Long trip. And this is what I have, over the years of dealing with this problem, we have noticed, and this is some varieties tend to be more susceptible than others. Everybody knows that, I guess, that is in this business. I've noticed that. It varies during the season, like I said earlier. Early and late parts of the season in Mexico seem to be more of a problem. And I agree, it is harvesting temperatures and environmental temperatures that makes a big issue. And in Georgia, it seems to be all throughout the season, because it's always hot in Georgia during the blackberry season, unfortunately. And I think also humidity might play a role. And in California, I don't have data from California like I have for North Carolina and Georgia. But we do have farms in California, and sometimes almost all of the fruit terms have the reversion issue when they are shipped to us from California to the East Coast. And first time it was, I think it was mismanagement of nitrogen. A lot of nitrogen was put. The grower was new, and he wanted a nice bush, and he put a little bit too much nitrogen. His variety was Primark 45. And it was a total disaster. We lost quite a bit of money in that time. And then we kind of managed that. But I think it's also almost 100% of the California blackberry industry is under tunnels. And California can get really hot. And we've seen the hot days or hot weeks that they have these waves. Every time that happens, we expect a lot of regression from California. So California is, with Primark 45, it's pretty hard to be successful. A lot of red sales from California. So the issue is that it also develops. The grower brings you a bright, black, nice, shiny fruit to your cooler, and he sees it, and he said, and then 3 or 4 or 5 days later, I tell him, hey, we got a rejection on your fruit, and and they don't say, but I gave it to you really nice, so it must be your fault. Well, that's the other issue. This thing develops over time. It can develop after the pre-cooling. It can develop at the cooler, so it can take a few minutes to 2 or 3 days later is all red. So that's also another issue. And of course, the harvest temperatures differential and how you cool it, we notice. And the speed of cooling, I had a talk with the Tasmanian doctor when he was a PhD student, and it's interesting. I think the speed of cooling. Previously, in my other job, we did something similar, and my experience with that was that if you cool off too fast, you create like microscopic cracks on the cells because it shrinks. It takes the water too fast. It just shrinks it too fast. And, the oxidation happens or this discoloration happens, and it makes sense. Maybe in my non-scientific kind of mind, that's how I figure it out. But it does have to do with the speed cooling. We have also tried it with these super pre-coolers called max coolers that have 4 chambers, and each chamber you can have different temperatures and slowly take it down. Those max coolers are quite expensive. They're between $700 and $1 million each. Wish Farms has one here at our plant city. We use it for our strawberries. Unfortunately, we don't have blackberries to cool them off here. But that's probably a good choice of having one of those pre-coolers that cools it slowly. I think that might help a little bit. I noticed that it doesn't affect the flavor, and many factors involved in this thing, as Margaret pointed out, and I'm doing the same way. I do believe that more research is needed, and finally, we had talks with some retailers, and one of the major retailers, believe it or not, is finally thinking, it's okay to have a little bit more regression. So they are promising us, and Marvin is going to like this, that they're going to reject us less due to regression. That's what they said to us. That's what they promised to us, that even though that consumer poll that was taken, a lot of people always have seen the blackberries always with regression. So that's how they picture in their mind. They got to have it. Yeah, a nice black shiny fruit is better, but you basically never seen one in the public, I guess. So they understanding, and they might be changing. So it is a work from all. I mean, we as shippers, we fight for the fruit to stick at the retailer level, for them to accept it, and we challenge them quite a bit. And due to this consumer retail is accepting that in the future they might be able to offset more of this on their fruit. So we're making headway on that one. And like Margaret said, we'll be live during the presentations for any questions. And we always open for any comments. You can shoot me anything you want, and comments or anything, and we'll try to do the best. Now, next one, I guess, Margaret, it will be the grower Marvin Williams, correct?
Yes, that's right. So our next speaker will be Marvin Williams, who is a grower in Georgia, and he will give us a little bit more of his perspective on this issue.
Margaret, can you see me? I'm Marvin Williams, and I come from Enigma, Georgia. I ship through Wish Farms. Hosea is a marketer and a handler for me. We've done some personal experience with this over the years. We found some things that worked for us and some things that didn't. One of the things that we have found is that no 2 years are the same. And what is normal? Normal is the average of great extremes. In 2018, I had some regeneration issues that we was playing around with. In 2019, I had none. 2019 was an extremely dry year for us. Our rainfall was very minimum, very little humidity. Temperature was extremely high. We had some really hot temperatures in May and early June, but did not have the red cell or the regeneration. Now, personal experience is that we found that clamshells, once they are closed up, they don't need to be in the field more than about another 15 minutes. They need to be out of that field and need to come to a cooler. Now that's easier said than done. That has to do with what time of the day you pick. So what we have to do is our workers have a tendency to try to pick more boxes in the morning, and we have to limit the number of boxes they can take to the field in the afternoon in a way to combat this regeneration of these red cells to appear. Because in the heat and that berry being hot coming out of the field, when it closes up in that clamshell, it traps the heat in it. So what we're working with is we're trying to remove it as quickly as possible. But just getting them out of the field doesn't solve this situation altogether. Once they're in a cooler, we try with cooler trucks. We've had a little bit of issues at times with cooler trucks, because once you stack those boxes up into pallets, even though the air temperature in there can be in the 40s, it does not solve the problem because that heat gets trapped in those berries. This is also connected with varieties. If you're a grower, it won't take you long to figure out what varieties are more susceptible than others. Some of my favorite varieties that I love to grow, I have the greatest issue with on this because they grow well in our area, but they seem to have a greater tendency to turn back to the red cell. So we went through several processes of trying to do various things. I've handpicked some berries for some individuals and put them in 1-gallon buckets. And I grew a particular variety that growed a large berry, and people loved it because it was pleasant to the eye, but I stick it in the refrigerator in a bucket. If that bucket's picked in the afternoon, on the top of that bucket, it will turn red, even though it's sitting in refrigeration. Now, if I pick it in the morning, it has a tendency to hold because the berry's cooler. These are just some things that we have done as our own personal experiments with these berries. But the temperature in the field probably has the greatest effect, and how long they are left in the field before they get to the cooler. We found that has an effect. But the other thing that I've experimented with, and I struggle because it's not as cool as they want. When I put my berries on that forced air cooler, and my room temperature is 35, 36, 34 degrees, I notice I get a little bit of regeneration sometimes before it leaves my cooler. If I leave the temperature in that room at 40 to 41 degrees, I do not see any regeneration of red cells. And I don't know whether it's because of the process of cooling them too fast. I don't know whether it's the process of the forced air changing the temperature at a rapid rate, or whether it is something in the force of the air going through it, or whether it's just simply leaving the temperature in that room not so cold so that you're not drastically shocking that berry as you pull that cold air through those boxes and those clamshells. But 41 degrees is not, or 40 degrees is not what my marketer, Jose, wants that berry at. He wants it colder than that. And so in order for me to get it colder, I have to turn the room down. And like I said, certain varieties picked in the afternoon in the heat of the day, forced aired, sometimes show more significance of it. I also believe that it's really not as much of a problem in the quality of the berry as many people want to think it is. I think if we could educate and enlighten the consumer on this, it would help, because I know I was watching some cooking shows, one of them being Chopped, and they had some blackberries that was on that table. And when each one of those cooks, when they took out those blackberries, I noticed they had some regeneration of red cells that was in there. They were not bright red, they were the maroon color, which is somewhat typical of what we see. And I thought to myself, well, why is this a problem? If this is a major problem, then why wasn't it acknowledged on this cooking show? Because of course, if the consumer tastes that berry, even though that cell has went back red, they will not notice. I do not believe, I've never tasted any difference in the flavor or even the certain varieties we grow. You just can walk in the cooler and you can smell the aroma of those berries. And I've never noticed any change due to this red cell issue. So I feel like, just personally, I'm not a scientist. I'll leave that up to Margaret. And I'm not a marketer. I'll leave that up to Jose. I'm just a grower. But my job is I'm trying to produce as good of a quality of a product, get it to my marketer, and then it becomes Jose's problem if it's not right. But I try to hand him the best quality product that I can for the consumer, because truly our greatest desire as a grower, we have grown a product and we want to share it with the rest of the world, and we want to share it with the consumer. And in our efforts to do this, And in the struggles, we have to battle environmental conditions that we have no control whatsoever on. But if we can come to a place where we can eliminate the factors that we know that are causing this, then sure, we do it. But I've been growing blackberries since 2002, started with a company named Sunny Ridge. Back in the day, that was the first. I didn't even know blackberries could be packaged in a clamshell and sold in a grocery store prior to me growing them for them. And, we've seen better varieties come along. We've gotten some genetic things that have worked better, some things that have helped us to deal with the environmental changes that fluctuate from the extremes of one year to the next, to the lows, to the highs. And so we've been able to, I feel like, come across with a pretty good product. But we want that consumer to know that we're producing the best product we can for the market. And we want them to try it, because outside of our efforts to do that, there's not a whole lot that's left in our capability to control. And the red cell, I noticed y'all cited the gentleman that did the testing with the nitrogen. I've even done some testing with that. I've never went as high as 189 pounds, but I've been as high as 90 pounds, and I've been as low as 40 pounds. And I really didn't see, I still had the same regeneration process of those red cells in the low nitrogen as I did the high nitrogen. So I don't believe in Southeast Georgia that the nitrogen, unless you got above 100, would be any problem. But I do believe humidity and temperature, atmospheric conditions, have the strongest variable in the field. And then the second area that I think it is in cooling down and how quickly we cool down. Jose, actually, I worked with Sunny Ridge years ago, and I know when we was first growing, Mexico berries had some issues, and when they would haul them out of the Mexico on those semi trucks, they would notice the top layer and the front pallets that was the closest to the cooling unit. But they were exposed to the greatest amount of cold for the longest period of time, had the most regeneration of the red cells. So I'm still leaning back. There may be things we can do genetically with the plant. That's Margaret's area of expertise. There may be some things that we can do in the cooling industry. That's Jose's job to tell me what that is. But as a grower, getting that berry out of the field as quickly as you can, getting it into a cooler environment. And if you're going to palletize it, put it on a pallet, stack those boxes on each other. You really need to be able to push some air through there as quickly as possible. I have heard of a little bit of playing around with ozone and ozone machines, fighting the mold. And in these countries where they have hot climate and don't always have the access to cooling units, they've used ozone generators. That seems to have helped in some areas. Now, they played around with that. I don't know that it's helped with the regeneration or caused it to lessen the red cells, but I do know that there has been a few places that they have tried to see if it helped that quality of berry. But then again, they're not exposing it to the cooling temperatures for hours. So I don't know how that's going to work out. And those are just things we see coming in the future. Like Jose and Margaret have said, we will be around. I know these are these sessions after we will be live, I guess, to answer questions. I don't know that there's that much I can add to it. Like I said, we do have varieties that we struggle with more so with this red cell than we do with others. But outside of that, not a lot I can probably infer into this conversation. But I appreciate you taking the time, and NARBA is doing its best to create these educational sessions so that we have this continual growing platform. And I know NARBA has really tried really hard in order to do that. And the best thing that we can do as growers is to continue to educate ourselves, continue to know the varieties that are out there so that we can produce the best quality, because it's in our best interest that no matter who is growing blackberries, that we all produce as best of it, or the best blackberry that we possibly can, so that we can, enhance consumers' trust in the product that we're putting on the shelf. But I thank you for your time, and I'll turn this back over to Margaret.
Thank you very much, Marvin, and thanks, Jose. Lots of good information there, and we went a little bit long, and I'm the primary culprit there. I apologize, but hopefully we can stay on a little bit over an hour to answer some of the questions and have a little discussion here. So please do put your questions in the chat, and thanks very much for joining us and for your time today.